Once again, welcome to a new problem. This time we have a forearm that's stretching all the way out. Okay, we have a forearm. Maybe we need to change it a little bit. So we have a forearm that's stretching outwards with the fingers out like that. And there's a socket, there's a bone socket at the shoulder. And then there's a joint right there. It's not 100% accurate, but we're just going to go ahead and use this. The thing that happens is there's a force that's pulling upwards at an angle of 15 degrees. So, there's this force, we're going to call it Fm, at an angle of 15 degrees. And then there's another force opposing that motion. We're calling that an angle of theta. We're calling that force Fj. The distance between the shoulder socket up until the Fm force is 12 centimeters. And then the distance up until where the weight acts, the weight of the arm acts, is an entire distance of 24 centimeters. So this is the information that we're given, and we'll see that in part A, we want to find given the total mass of the arm M is 3.3 kilograms. We want to go ahead and find in part A the force Fm. So what's the magnitude of the force Fm? And then in part B, we want to find the magnitude of the force Fj and the angle theta. So this is the angle theta right there. Those are the two issues we're dealing with in this problem. So the first part, we're going to say that the sum of torques is 0, assuming the torque from the bone socket is our main interest. We'll see that Fm sine of theta obviously is a component of Fm. It's a component of Fm. So Fm sine of theta times 12 centimeters becomes equal to mg times 24 centimeters. That allows us to compute Fm as being equivalent to mg 24 centimeters, all over sine theta, 12 centimeters. But then sine theta is 15, so this is mg 24 centimeters, all of sine of 15 times 12 centimeters. Next page, we start plugging in those numbers to get Fm. So we see that Fm is 3.3 kilograms times 9.8 meters per second squared. And we don't have to do the conversion to meters, even though it helps, because the centimeters are going to cancel each other out. Sine 15 degrees, 12 centimeters. These 2 centimeters cancel out, so then Fm is approximately equal to 250 newtons. That's Fm is approximately 250 newtons. The next part of the problem is part B, where with the assistance of free body diagrams, this is mg, this is Fm, and this is Fj. There's an angle theta that J makes with the horizontal, such that it has 2 components, Fj sine of theta And then there's another component this way, which is fj cosine of theta. So this component is sine of theta, and this component is cosine of theta. We repeat the same process for fm. So fm has a vertical component, fm sine of theta, and it has a horizontal component, so fm cosine of theta. We know the sum of forces in the x is 0 because the system is in equilibrium, so fm cosine of theta has to be equal to fj cosine of theta. The intention is to not to say theta for fm, but to say sine 15, since we don't know what theta is in this problem. So then this is sine of 15 degrees, like that. Fm cosine of 15 so fj is equivalent to fm cosine of 15 over fj, or rather over cosine of theta, So that's what fj is. We're going to continue and say the sum of forces in the y direction is 0. And that just means that these two forces are pointing downwards. So this is going to be negative, and that's negative, and this is positive. So we're saying fm sine of 15 degrees minus fj cosine of fj sine of 15 sine of theta minus mg equals to 0. So those are sum of forces in the y direction. We want to solve for fj, and we do know that fj is in terms of fm, so we'll take this fj and plug it into the formula right there. But prior to that, prior to plugging in, we can say that we already have the solution for fm. So if that's the case, if that's the relationship, so we get to see that fj sine of theta equals to fm sine 15 degrees fm sine 15 degrees minus mg. Okay, that's what we have right there. And then since fj is right here, we're going to replace that and say fm cosine of 15 all over cosine of theta times sine of theta equals to fm sine of 15 minus mg. But remember that these two, cosine theta and sine theta, is the same as tangent of theta. It's going to be helpful. So then tan theta times fm cosine of 15 degrees equals to fm sine 15 degrees minus mg. So in the next page, we'll go ahead and say our target is to solve for tangent of theta. So tan theta equals to, if you go back, you see the relationship. There's an equal sign there. So tan theta equals to Fm sine of 15 minus mg all over Fm cosine of 15 degrees. Theta has to be tan inverse of this relationship, which is 250 newtons times sine of 15 minus mg, which is 3.3 kilograms, times 9.8 meters per second squared, that's g. All of that has to be divided by 250 newtons times cosine of 15 degrees. And then we have theta being equivalent to 7.63 degrees. That's going to be helpful in helping us solve for Fj. Remember, Fj is Fm cosine of 15 over cosine of theta. So we'll say next page we have Fj is Fm, just to make sure, cosine of 15 over cosine of theta, but then theta is 7.63 cosine of theta. So this is 250 newtons times cosine of 15 degrees, all over cosine of theta, which is cosine of 7.63 degrees. And so Fj becomes equivalent to, if you plug in the numbers, you get 243.6 newtons. So hope you enjoy the problem. Feel free to send any questions or comments, and have a wonderful day.